and they're also this document is in Google Classroom as well. The assignment is on Delta Math. So I know we've used it once before, a couple times before. We're going to be using it again for this assignment. So we left off with example K. So again, if you are multiplying two binomials together, so our end goal is to be able to factor these trinomials within seconds is the whole idea. You should be able to factor these basic trinomials within seconds. But understanding how the binomials are created, how the binomials become that trinomial or that basic trinomial is key to being able to factor it. So once again, from a review from yesterday, when you have two binomial factors, and you're asked to simplify or multiply them together, we are going to basically distribute the x or the first term here to the first term there. So that's our first terms. X times x, which is x squared. Then you distribute the first term to the last term. So we call those the outside terms. So the x times the negative 11 would be negative 11x. And then you would distribute the 3 to both the x and the negative 11. So the 3 times the x, those would be your inside terms. And 3 times x is just positive 3x. And then you take your 3 times your negative 11, which are your outside terms. I'm sorry, not outside, last. So we end up with this acronym FOIL for first, outside, inside, last. And we only use this when we're multiplying two binomials together. So your last terms again, positive 3 times a negative 11 would be negative 33. So we originally have 4 terms, but then we look for like terms and combine them. So the x squared does not have any like terms, but your negative 11x plus 3x, because the signs are different, you actually subtract 11 minus 3 and get 8. But then because the larger number is negative, it will be negative 8x and then minus 33. So this is now our trinomial, our basic trinomial. And that's the product. Okay, so now we are working backwards. We're given a basic trinomial product, and we need to figure out, your goal is to figure out what the two binomial factors are that would multiply together to equal this in the first place. So another thing I wanted to point out, the negative 33 comes from multiplying 3 times negative 11. But the negative 8 comes from taking 3 plus a negative 11. So when you look at these two numbers, they're the same number, but they multiply together to equal the C value or your constant, and they add up to the B value or your middle term. So that knowing that will help us with factoring this here, because we're basically going to first of all set up. So my suggestion is that you set up your two binomials. So if A basic trinomial can be factored. It will be factored into two binomials. And it's a basic trinomial because your a value is 1. Once your a value is not 1 anymore, then we're going to have to use a different method. Well, good morning, and thank you. Because this is k squared, these two first terms, so just like before, the first terms multiply together to equal the first term in the binomial. So these are the trinomial. The first terms here have to multiply together to equal k squared. So hopefully that makes sense. So that would just be k times k to get that k squared. But then figuring out the numbers is sometimes a little bit tricky. So we have to ask ourselves the question. Make sure you know this is all mental steps. This is a mental step, and you need to know what the question is that you need to ask. So the question is, what two numbers multiply to equal negative 48 and have a sum of negative 2. So the negative 48 is your C value. The negative 2 is your B value. So a lot of times what I'll suggest to students as well, if you have difficulty with figuring this out, is to make an X and put the C value on the top, negative 48, the B value on the bottom, negative 2, and then try to, again, think of two numbers that multiply together to equal 48, but that has to be negative 48. So if it's a negative 48, what does that tell you about the signs of your two numbers? One has to be negative and one has to be positive. They have to have different signs. If the signs were the same, then that 48 would be positive. So because they're different, actually, instead of thinking sum or adding, because when you add two numbers that have opposite signs, you technically are subtracting and then keeping the sign of the larger value. So think of two numbers that multiply together to equal 48, but have a difference of 2. So what would two numbers be that would multiply together to equal 48 that have a difference of 2? And if you can't think of the numbers, make a list of the factors of 48, starting with 1 and 48. Then go to 2. 2 goes into 48 24 times. 3 goes into 48 16 times. 4 goes into 48 12 times. 48 has a lot of factors. 5 does not go into 48, but 6 goes into 48 8 times. So 6 and 8 have a difference of 2. But the signs are going to be different. So, and we want them to add up to, we want it to be a negative 2 when we add them together. So the larger number needs to be negative. So the 8 has to be negative, the 6 has to be positive. So once we figure out those numbers, those are the two numbers that go here and here, because they add up to negative 2, but they multiply to give you negative 48. And these are your binomial factors. So step 1 is basically to set up the parentheses and the variable. And then step 2 is to figure out what your two numbers are, and then just put them in the binomial. Questions on that example? So the better you know your factors and your multiplication facts, the easier factoring is for you. All right, so the next couple examples, we have a multi-step where we're going to include the two things that we learned how to do in this lesson, and that's factor out a greatest common factor and factor a basic trinomial. So if you look at this example, always when you're factoring, look for common factors that you can factor out first. So if you look at all three terms, what's a common factor that all three terms have? 2. Good. So, and then look at your variables. Do they all have a variable? Yes or no? No. Only the first two have a variable. So we cannot factor out a variable if they don't all have it. So that's the only way you can factor out a variable, is if they all have that same variable. But they do all have a factor of 2. So we're going to factor out, let me change my color here. We're going to factor out that common factor of 2. So the 2 would go on the outside, and then you would basically take each of these terms and divide them by 2. So that's how you get what's left inside. So when I divide this first term by 2, I'm left with p squared. When I divide this by 2, I get just p. When I divide this by 2, I get negative 12. So now inside the parentheses, I still have something that can be factored again. So we're not done until we factor this completely. So this is now a basic trinomial because its a value is 1 and it's 3 terms. So now we're going to factor this basic trinomial, starting with the setup. Set it up into 2 parentheses. The first term in each of these binomials has to multiply together to equal p squared. So the first term in each binomial has to be p. But then we need to figure out what the numbers are that go in the other part of the binomial. So we do need 2 numbers that multiply. So the question is, I'll just put it down here. What 2 numbers multiply to equal negative 12 and add up to a positive 1. So if you don't have a b value, the unwritten coefficient is 1. So if you make that little x, put your negative 12 or your c value on top, put the positive 1 on the bottom. So if they have to multiply together to equal negative 12, you should know that the signs are going to be opposite. One's going to be positive, the other is going to be negative. And because they're different, think of 2 numbers that have a difference of 1. So 2 numbers that multiply together equal 12 and have a difference of 1 would be 4 and 3. If you can't figure that out, make a list of your factors of 12. Starting with 1 and 12, then go to 2 and 6, and then 3 and 4. So these are all the factors of 12. So if we have a positive 4 and a negative 3, they would multiply together to equal, so they would multiply up to negative 12, they would add up to positive 1. So hopefully that makes sense why I say find a difference of. When the signs are different, think difference. All right, so positive 4, negative 3. And we're done. Okay, so now it's factored completely. And these are your factors. So you have a factor of 2, you have a factor of x plus 4, you have a factor of x minus 3. If you were to multiply those back together, it should equal this trinomial that we started with. Okay, the next one is again a trinomial, but we have a leading coefficient that's negative. You never, ever, ever want to factor when your leading coefficient is negative. Always factor out the negative if the leading coefficient is negative. So we had an example like that earlier where we factored out a negative. I think it was the very beginning. Let me see if I can find it. So right here in example D, we had a -9, a +12, and a -6. So you could divide all of those coefficients by 3. But because the leading coefficient was negative, instead of just factoring out 3, you should factor out -3 so that you end up getting a positive value here. It looks like we forgot the square there. That should be a square. Well, in this case that we're doing down here, this example down here, is there a value we can factor out or a number that we can factor out of all 3 terms, like the 3? Can all of those terms be divided by a 3 or by a 2 or something like that? Yes or no? No. But the leading coefficient's negative, which means if we can't factor out something like a -3 or a -2, you at least have to factor out a -1. So sometimes it's just a -1 that you have to factor out. So if I put a -1 on the outside and then divide all of my terms by -1, that basically is just going to change all of your signs. So eventually this is going to be a mental step as we move along. But for right now, I'm just showing you where those things come from. So the -1 stays on the outside because we factored it out. And then when we divide everything by -1, we get a positive x squared. But the 14 now becomes negative, and the -45 is going to become positive. So now again, we have a basic trinomial. So go ahead and take a minute, see if you can factor this basic trinomial into its 2 binomials. That's not what I meant to do. So let's think about our signs for a second. In order for the 45 to be positive, what does the signs of the numbers here and here have to be the same or opposite? Here they're opposite. But if your signs are opposite, if you take a positive times a negative, will you get a positive? No. So whenever your C value is positive, you must have the same signs. But if they're both positive, would they add up to a -14? Is there any way 2 positives could add up to a negative? No. So they cannot be both positive, so they must be both negative. So what 2 numbers then would add up to 14 and multiply to 45? 9 and 5. But they have to both be negative. So the negative times a negative is a positive 45. Negative plus a negative is a -14. So these are now your factors. I cannot spell today. So -1 is a factor, x minus 9 is a factor, x minus 5 is a factor. All right, so on this last page, I basically summing up the sign rules. So it's important that you understand the basic rules for your signs when you're factoring basic trinomials. This also will be helpful when you're doing the trinomials that are not basic ones, where your a value is not 1, but all right, so if the c value is positive, so I've got x squared plus bx plus c and x squared minus bx plus c. So your c value is positive. So just like that last example, whenever the c value is positive, that tells you that you have the same signs. So that c value should be the first thing that you look at. So when you're trying to determine the signs, first look at the c value to determine if your signs are the same or if they are different. So if we do the little x thing here, your c is positive something, or let me do this different. So you have a positive c and a positive b. They have to multiply together to equal c. They have to add up to that positive b. So the positive tells you your signs are the same. But this tells you they have to both be positive. So when you are factoring the basic trinomial, if you have x squared, you have x and x, you'll have two positive numbers. Because when you multiply a positive times a positive, you get a positive. A positive plus a positive is also a positive. Now, if your C is positive, but your B is negative, so they have to multiply together to equal positive, they have to add up to a negative. So again, the positive C value tells you you have the same signs. But in order for them to add up to a negative, they must both be negative. And then whatever the numbers are. So you have to have a negative and a negative in order to add up to a negative. So when you're factoring a trinomial like this with those signs, it's going to be x minus something and x minus something when you're factoring. So basically they are the same, but they're both negative. Here, your signs are the same, and they're both positive. All right, so then what if your C value is negative? So if the C value is negative, then the signs have to be different. And the larger number will be the sign of the B value. So if you get a trinomial like this with these signs, set it up, but then your signs will be different because that C value is negative, and the larger number has to be positive. So when you are doing your little X game thing, If this is negative, if the C value is negative, you're going to have different signs. One's positive, one's negative. But if the B value is negative, then the larger is positive. So this one's going to be the larger number, and this one would be the small number. And then if your B value is negative, again, the C value being negative tells you, number one, that you have different signs in your binomials. The B being negative, look at that second, tells you the larger number is negative. So when you're setting it up, your signs have to be different. Doesn't matter if you put the plus first or the minus first, but this one, so they're different signs. But the larger number has to be negative in order to get this negative B value. And if you're doing the little X thing, your signs are going to be negative, positive. The negative is going to be larger. The positive is going to be the small number. All right, so now your goal, I'm going to give you a few questions, see if you can factor these things in 30 seconds or less. Okay, so are we ready? Any questions before we begin? To the left? Mm-hmm. All right, so here we go. Problem number 1. You have the trinomial x squared plus 9x plus 18. Factor it. Go. All right, anybody done? 30 seconds are up. Set up 2 binomials. X squared is x and x. What are 2 numbers that multiply together to equal 18 and add up to 9? If you don't know your factors of 18, start with 1 and 18, 2 and 9, 3 and 6. So your numbers are 3 and 6. Are my signs the same or different? What does the C value tell you? They're the same. They're both going to be positive, and you're done. So those are the plus ones are the easiest. All right, let's try another one. X squared minus 11x plus 28. 30 seconds, go. 30 seconds are up. Did you finish it? All right, let's see. So set up the two binomials. Your x squared factors in x and x. We need to find two numbers that multiply together equal 28 and add up to 11. What are the numbers? Yeah, 7 and 4. Will my signs be the same or different? So this tells me they have to be the same signs. You can't have different signs and have them multiply together equal positive, but they must both be negative. So if you're going to do this thing over here, they multiply together equal negative 28. They add up to negative 11. So 7 and 4 do multiply together equal 28. They also add up to 11. But in order for them to add up to a negative 11, they have to both be negative. How'd you do? Okay. Now let's try one with some different signs. Okay. X squared plus 4x minus 32. 30 seconds. Go. X squared plus 4x minus 32. All right, 30 seconds are up. Set up your two binomials. X squared is x and x. The little thing over here. So your C value is negative 32. So that negative means your signs have to be different. So if they're different, think difference. Two numbers that multiply together equal 32 but have a difference of 4. What are my numbers? Just say it if you know it. 8 and 4. If you don't know them, list your factors off to the side of 32. 1 times 32, 2 and 16. 3 doesn't go into it. 4 and 8. There you have it. Now, in order for them to multiply together to equal a negative, your signs have to be different, but the larger number has to be positive. So the 8 has to be positive, the 4 has to be negative. In order for the two numbers to multiply together to equal a negative 32 and add up to 4. So these are the type of polynomials that you factor over and over and over again in every math class from here on out. You will struggle tremendously if you cannot do these quickly. So we're going to keep working on them until we can master this. All right, last one. X squared minus 6x minus 40. 30 seconds. Go. X squared minus 6x minus 40. Okay, 30 seconds are up. Set up. X squared is x and x. Then off to the side, my C value is negative 40. My B value is negative 6. They have to multiply together to equal 40. However, instead of thinking add up to 6, think difference of 6 or subtract to equal 6, because your signs have to be different in order for them to multiply together to equal a negative. So two numbers that multiply together to equal 40 but subtract to equal 6, 10 and 4. But in order to get a negative 6, the larger number must be negative. The larger number is 10. The smaller number is 4. So negative 10 and positive 4 are the two numbers that you put in your binomial factors. Okay, so hopefully you've realized that finding and knowing the factors of numbers is going to be very helpful in factoring. So I have actually put together a factor sheet that I'm going to give you here in just a second. Let me find a copy of it to show you what it looks like before I hand it out. Okay. Okay, why can't I find it? All right, well, I'll just hand it out and I'll just kind of make a copy of it. And if you fill out this factor sheet, I will actually let you use it on your quiz. Now, when it comes to the test, you're going to have to do without. But you can use this on your homework, you can use this on your quiz. And I would actually recommend that you hold on to this factor sheet as a reference for any math class that you take beyond this one. Factoring is a skill that you have to master in order to pass this class and the next class and the next class and the next class. Okay, so the idea with the factor sheet is that you have a list in front of you. Instead of having to make a list every time you have a new problem, if you have this list in front of you, now this includes all the numbers from 1 to 100. Now, will you have some problems that have a C value that's bigger than 100? Yes, but at least this will help with a lot of those main problems that you're going to have. All right, I'm waiting for this thing to... So in the first row, you've got 1, 2, 3, 4, 5, all the way to 10. So the idea is for you to list the two numbers that would multiply together, or any numbers, integers, that would multiply together to equal 1. Well, 1 and 1. You don't have to put a time sign, just put a comma. So 1, comma 1. So whenever your C value is 1, the only numbers that will multiply together to equal 1 are 1 times 1. The only numbers that you can multiply together to equal 2 would be 1 and 2. Now, sometimes the signs are going to be the same, sometimes they're going to be different, sometimes they're both positive or negative or one or the other, but at least you have the numbers there in front of you. And then the only numbers that multiply together to equal 3 are 1 and 3. 4, you can use 1 and 4, but also 2 times 2. 5 is 1 times 5, and so on. And then in the next row, you've got 11, 12. So 12 is a little bit more interesting. 12 has several numbers. So always when you're making your list, start with 1 and the number itself. Then go to 2. 2 goes into 12 6 times. Then go to 3. 3 goes into 12 4 times. 4 is after 3, but 4 is already in the list. So once you get to a number that's on the other side, you're basically done with your list. So like 16 is another one that has a lot of factors. Start with 1 and 16. Then go to 2 and 8. 3 does not go into 16, but 4 does. 4 and 4. So once you get to the other side, or once you get a number that's on the right, then you know you're done. Let me see. Another one, 48. Let's do 48. So 48 is near the bottom, left side. So start with 1 and 48. Then go to 2. 48 divided by 2 is 24. Then 3. 3 goes into 48 16 times. 4 goes into 48 12 times. 5 does not go into 48. 6 goes into 48 8 times. 7 does not go into 48, and 8 is already in the list. So since we've gotten to that right side, now we know that that is all those that represents all the factors of 48. Does that make sense? So yes, this is going to take a few, some time to fill out the 1 to 100, but I'm telling you, this will be extremely helpful. Those who fill it out and use it to help you with your factoring, it will be very helpful to you when you're trying to think of those numbers, because it's not always the most obvious ones like 6 and 8. Sometimes it'll be 2 and 24 or 3 and 16 or 4 and 12. So when you're factoring, you don't always use the most commonly used factors of a number. All right, so 2 things now to work on. Complete your factor sheet. And then complete the Delta Math assignment. And do not cheat yourself from learning by trying to use online websites or apps on your phone. That is you're only cheating yourself if you're going to do that, because they're going to teach it differently. They're going to have some weird stuff going on. And I know that happened during COVID, but we're at a point now where you have to learn this. If you do not learn this, you are going to regret it. So you have to be able to do this without technology. The only thing you should be using is maybe a calculator, but do not use the internet to help you factor. That's factoring is the number one reason why people do not pass this class, because they rely on those other sources and it ends up really hurting them in the end. So, all right, I'm done talking. Let you have these last few minutes to work.